All right. We're live for day 23 of Having a Code. 3 days left. Only only two full nights of problems. 25 is always an easy one. I feel like either today is going to be really hard or tomorrow. Surely one of them has to be, right? Let me mute this. All right. So, what did we 15 minutes might be enough for a warm-up problem. We could look at day 22. These always reference a past one. Oh, I know what this is referencing. The jungle from 2 years ago. And I remember the monkey problems having a reputation. Ah, okay. Some people hated this problem, but I think I actually really enjoyed this. Let me pull it up. Day 11, 2022. I just want to reminisce with the historian. Wait, where are you? There we are. Yeah. So in this problem, each monkey sort of had its math operations. If true, throw to monkey 2. If false, throw to another monkey. So how did I parse this? So throw 2, I turn into a vector of long to int. Why long to int? I guess that's where it's being thrown to. Yeah, so we do if true and if false, the place where we throw them. So this is the condition, and then true and false. And we just interpret this right away, I suppose. No, this returns a function. Okay, right. So the vector of functions. And the vector of the worry is also a vector of functions. So how did I use those? Power issues. Yeah, I think I just applied them by the monkey's index number. Oh no, did we lose our... Here we go. Okay, but this was a fun one. I don't remember what the tricky bit was. It was just simulation for the most part. It's a final question. What's the level of monkey business? What is monkey business? You multiply that. Oh, okay. All right, that was a fun one. I'm remembering 13 as also being a fun one. Oh, yeah, 13 was... Okay, maybe we're not warming up, but we're just reminiscing. No, this is the wrong date. We want day 13, 2022. Yeah, this was very nice because I could define a recursive ordering like this. And I could use that. I mean, I could define the ordering recursively. then depending on its own definition to recurse into it. So in other languages, you'd have to handle this recursion yourself, and it's super simple to sort these by these custom rules by defining an ordering in Scala. This is a bit of code I'd like to highlight sometime, but it was super pleasant to write, and I'd hope it's pleasant to read too. Okay, where are we? 2024. I could just refactor this a bit while waiting for the problem to get in. We've got about 8 minutes left. One thing I didn't like about this was that all these are individual functions that we then have to pass a secret to. I want to see what this looks like if we just had these as values. So let's define this bit here. I guess repeat it as just steps. Def steps given a starting secret. Hey, Hellhound. How are you? Do you think tonight's will be a tough one, or will the tough one be tomorrow night? I suspect that the one a couple nights ago, 21, was it 21? I suspect that might end up being the hardest one of this season. It's usually the weekend before that has the hardest one, right? Although I guess today's part of the weekend. Do you see the lights going out? I don't know why that's happening. Okay. I don't know about this last one. Where was I using that? Let's see where we end up using that. You're excited? 3 days left. Today will be a hard one. Well, I think I prefer today than tomorrow to be the hard one. Day 23, my first year, I struggled with. And I eventually ended up doing it by hand. It took me so long that it was faster to do it by hand. I couldn't prune my search state enough. That was the amphipodes one, if you remember it. What can we do here? So let's say val prices equals steps dot map this thing. Okay, and then we'll just define the deltas from here. You love the amphipodes one? Yeah, I really enjoyed that one too. And I enjoyed it more. I had to like solve it in code after the fact, and once I got it, that was good. But it was interesting to me that it was small enough. You could just do it in pen and paper in 15 minutes. And you would have gotten a pretty good rank just doing it in pen and paper. Nathaniel, I don't think I've seen you chat here, by the way. Welcome, welcome. Yeah, we're almost at the end. I feel like we need to celebrate decompress when it's all done. I don't know what to do. I want to do some kind of a retrospective. It'd be fun to hear kind of everyone's thoughts on their favorite problems from this year. Maybe a tier list would be fun to do. Yeah, we're there. We're bracing for tonight to be a hard one. It is still part of the final weekend. You've got an Eric in chat. If I do this, hmm, I think I want to make this a lazy list actually. And then this one would just be um, map, I guess, steps. Um, and then 2000 dot sum. And we're going to take out these steps. You had an idea for Reddit fun, but you were tired and skipped this year. Oh, what were you going to do on Reddit? It's true. Every time he shows up, we have a bad time. He shows up because he knows. He wants to see us suffer. AOC themed version of Game of Thrones. Oh, really? Okay, hold on. I want to pull that up. Um, hmm. Eric just wants to see us suffer. That's what I'm saying. He's here to see us suffer. Lieutenant Hummus, how'd my day 21? Is that the one where I stayed up until 7 a.m.? So I stayed up until 7 a.m., but it's done. It wasn't so bad. I should have finished at 4 a.m. because that's when I solved it, and my 7 a.m. solution was basically 4 a.m. Just add a memo. I took a little detour trying to find an optimization. But good to have you, Hummus. Good luck, Michael. You just straight up noped out. I respect that. You probably saved yourself a night of sleep. Okay, I want to see this Game of Thrones thing. Um, I'm not seeing it. I might need someone else to share the link. I didn't do anything clever for yesterday's, but I'd kind of like to optimize it. Oh, this is the cheats. That diamond could be a big spoiler, by the way. I was accidentally searching in a square. Ah, there we have a link. And we have an alarm. 2-minute warning. I don't know what's going on here. I'm just gonna comment out everything right now. So that's not erroring out on me. So let me set up my worksheet. Um, uh, this is input. It's gonna be day 23. Okay, so we're set up. Wow. This is a lot of effort put into this, and there's visualizations for all the problems. We're not going to finish this before it starts. Oh, yes, the day 17. 14 and 17 are highlights for me this year. Oh, sorry, that's probably super loud, isn't it? Okay, 15 seconds. Good luck. Good luck, everyone. Let's see what we've got. Ooh. Okay, so we have a graph, a list of every connection, and what do we do with this? Let's skip to the end. How many contain at least one computer with the same how many what's? Find all sets of 3 interconnected computers. And how many contain at least one computer with a name that starts with T? Okay. Um, Start by looking for sets of 3 where each computer in the set is connected to the other 2 computers. Okay. I just want to see how long the input is. This is probably manageable naively. We'll see. Um, do we turn this into any kind of a special map? Okay, so my strategy here could be to turn this into a map from KH to everything it's connected to. We might want to normalize this first, so that the left one is always like alphabetically first. I assume the connections are bidirectional, so these edges aren't directed. And for everything KH is connected to, we could search in those, do an n squared for that smaller set, and check which contains the others. And each of those, each time we find one, that is a new set of 3. Okay. Do we have day 23? No, we were downloading 22. All right, we've got our input. Val, we'll just call it our adjacency graph, map from a string. Let's make it a list of string. Okay, so we're going to take our input and do some parsing. Fun and short part 1. Are you done yet? So we have an A dash and a B. And I do want to normalize so that they're sorted. So if A is less than B, then A to B, otherwise B to A. Okay, and the next step, we're gonna just group by identity. Not exactly just that, we're gonna group map. Not grouping by identity, but we're grouping by one of the tuples. So group by the key, and keep the other end. And that should do it for us. Okay, you've got our adjacency graph. And then to get all the trips, and then what are we trying to do with them? How many contain at least one computer with a name that starts with T? Okay. And I'm hoping, I think I should only get each trip once, right? Since we've normalized by an alphabetical order. So, edge dot flat map. So case we have key, and then we have a bunch of values. So these are candidates for being part of the triple that includes this k, right? And with this, we're going to get combinations of size 2. And I suppose we'll filter. I'm going to call this A. We're going to have A, B, and C. So now we have a B and a C. And we want to filter if edge B contains C, or edge C contains B. That'd work. I wonder if I should make this a set. It's probably fine. And then, yeah, I guess that's the trips. So we flat map it into all the combinations of 3. And I'm assuming those are all going to be distinct. I suppose I could take it into. So this is going to be the list of all, a bunch of list of tuples, isn't it? I think after we get that list of tuples, we're just going to cons A onto it. So we're going to do a map A onto that list. And this is going to be a list of lists, I guess. Okay. And then trips.count case list A, B, C, or we don't need to structure it. We want to count them such that one of them, there exists a computer that contains just the letter. Starts with T. Starts with T. And that's our ans 1. Okay, let's fix the compiler errors. You hacked together in super slow and running, but you got part 1 answer. Great. A LAN party. A LAN party sounds fun. You need a brand new solution for part 2. Key not found. Oh, yes. We're just going to map this with a with default value of nil. Okay, 1476. Hey, that didn't seem to have any performance issues. Yes. Oh, and I'm still top 1,000. Okay. Well, let's see if we can get a good delta, because I don't seem to have any issues with performance. Way too many results to go through them all. You'll have to find a LAN party another way. The The LAN party will be the large set of computers that are all connected to each other. The largest completely connected graph, okay? So I guess we do this filter, and then within that, we find a party. Fully connected. Okay, I think I will want a set now. Um, and then what's the password going to be? You just sort them in order. Code kata. Code kata. Fun. uh, yeah, I think we just need to make a set. And I'm operating on the assumption that it also has at least one that starts with T. So we know that that's true, right? Starts with. Okay. So we'll start with this filtered list of trips. I don't think we want trips anymore. Let me just do a quick save here, just in case I want to refactor things. Okay. 23. Okay. So we're turning this into a collect, and this is now guard. If that, then in this case, we would have returned a, no, list A, B, C. So that doesn't change anything. Let me just make sure it still works. And okay, so we don't want that list anymore. We just want the full set of these. Um, so one of those trips will contain everything. I think it's enough to have the A of those trips. So these are our candidates. About candidates. Well, and we'll just keep the A. And then we'll do a candidates dot filter. Or I guess we just do a find. So we find one such that for all of these, they contain the other, all the others, or one contains the other. We could sort them. So I think I assume they're sorted already. If we sort the whole list, I think this should be sorted. Oh, and then we put it into, well, what happened here? Oh no, why are you showing me all of that? Found A, right? So this is just going to be a list of string. I just want to see what this looks like. I feel like I'm taking a detour I shouldn't be doing. I should just solve it. TD Man, welcome. Hi. How's it going for you? Mm, Yeah, so we're going to find an A such that its adjacency. I guess we want the fees. Yeah, let's keep the fees. So I guess this is a list of string. And I guess v's such that v's dot I guess all the combinations of 2 are connected to each other. So v's dot combinations of 2 dot for all. Yeah. What did we do wrong here? A and B. Then we have either A, well, B contains C. Here we go. B contains C or C contains B. And then we probably want to turn those into sets. And then once we once we find that map, so we're gonna sort them, and we make the string with a comma. Okay. And before I even run that, I'm just gonna go ahead and do this performance optimization. We're just gonna map values here. So edge set, we want sets of strings. And it's just gonna be edge.view.map values to set dot to map. Okay, we don't want any performance issues here. And we're gonna use edge set down here. I've done the sorting. I think that should help, but I'm not relying on it right now. So find, we need a case here. Do we have other out than expected, but a parentheses was found? How about that? I'm not understanding this syntax error. I'm telling you, this new indents would be fine if the error messages were on par. I don't want to be fighting with this. So candidates not find v's, sure. Such that we have all of that. This map should be here at the end. V's are combinations of 2 for all of them. And this is a list of string. Right, so V's is a list of string. You got the sample answer for part 2. I mean, I think I should have this. What is a syntax error here? I don't know. Let's just put this on another line. Case V's. Oh, is it coming from like another line that's not completed? Okay, now the syntax error is shown up here for all. If. Why is there an if? Ah, okay. See, why would that syntax error there, having an if there, show up as that outdent error message here? That's That's not user-friendly. Okay, so I believe it should be trying to run. Yeah. Key not found. Right, let's do with default value. With default value set empty. Okay. Okay. Wait, why are there only 3? Because we're just okay. We find we're not doing any map on it. No. We want the largest. Okay. So we find fully connected components. So this is a filter, and then we sort, or we're gonna do like a max by dot size. Yeah, and the candidates, I suppose, should include the A. So we're going to do A onto V's. And since we know A is connected to all of these, we're just going to do V's.tail.combinations. Max by size, and then map this. Do we need to sort? I don't think we need to sort, but we're keeping the sort in the code anyway. That looks wrong. Why do they look like that? G and U? Space F, K, G, N. Did turning things into a set mess things up? What does this edge set look like? No, they are all sets of two letters, 2 characters. We're so close. We're so close. Come on. Okay, let's just see what that looks like. Oh, sure. So list of strings. So that's the largest component. Well, let's call it largest val, largest. Okay, so we're gonna take largest dot sort it. And what does that look like? Cool. And that makes string. And that should be our answer. Oh, make string with a comma. Okay. Val ends. Equals that. So this wasn't, well, I'm speaking too soon. Okay, that is not the right answer. Let's try it on the example. And see where we are off. You're wondering if it's more efficient to use Scala or stick with Java for your Flink jobs. Apache Flink. I'm not sure. Resource allocation and latency. I mean, they both do they both give you the same API? Well, probably not the best time to talk about it, but I wouldn't know. I haven't really used Flink. So this is day 23. Text 24. Okay, got your bug. Rank 913. Excellent. Okay, I'm gonna catch up to you in just a sec. Uh, okay, this is the set of computers that whatever had the connections. This is the example, um, right? And this should show up as code kata, right? It's not a different example. Okay. De kata. Oh, we just lost ko. Okay, we lost the first part. Ah, yeah. Shouldn't that be in here? Okay, so what's the largest? De taka. They're all gonna be connected to ko, right? So if we look at Aj Co. Whoops, not. Um, yeah, TC. Detaka. Okay, maybe this bug is more subtle than I think. It's not simply missing that first because we have, okay, so the candidates, does it even appear in here? So there are 4 bits, code kata. Okay, let's take, make sure we have the right candidates. So candidates dot filter dot size equals 4. And for each print line, I might not make the 1,000 here. I seem to have hit a little road bump. Um, and my worksheet doesn't seem to be running that. Is it running anything? Do you have another issue? I mean, sure. Oh, here. Candidates filter size equals 4. That's wrong. So what are we getting here? So we're getting the adjacency graph. We have the A and the V's. And for all those V's, we are collecting the combinations at size 2. Wait, what happened to the for all bit? Candidates. Oh, the candidates is the A's. Whoops, 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 whoops. Okay. Or like what you get from the A's. Wait, no, V's is the whole thing before we get the combinations. Right? Like, it's just these lists flattened. It's just the A and the V's. But we flat map onto multiple of these every time we have some combination of 2. Right, we just know that it contains it contains that triple. So this should be a list of keys. Okay, yeah, I see. This candidates doesn't really help us in this way. Maybe I'm not gonna start from there. Let's see if this works just fine if I go over everything. So we're gonna do like I don't know, edge.values.filter, except we're missing the A. We're gonna do edge.toList.map k v's k onto v's. Okay. let's let that run. And let's just check. Like this should work for code kata. I mean, once it does run, I don't think it's run anything. Mm. Okay, well, we're waiting for the worksheet to catch up. I'm just gonna run this in the console. Which we can't do because my worksheet is not compiling. Oh, that's a real pain. I see. I should have cleaned that up before starting. Um, oh, who just got it? Oh, yes, you're celebrating blue. You tried Copilot today to solve? Hold on, I'll catch up with you in a minute. What's going on here? Okay, so well, it's just not even. It doesn't appear to be attempting to start the evaluation. Okay, there. Now it's running. Okay. You're still missing the co. So basically, we're taking everything now. So this is the more naive version. We're not filtering by using the candidates, um, and these are like all the values in there. And we are filtering by whether everything is connected to everything else, right? That whole tail is connected itself. Um, in fact, this filter, just gonna rewrite this real quick to be case K and V's. And I can remove this map here. So V's, every combination of two of the V's, they contain each other, right? One of the two contains the other. And then I suppose we map to cons them together. K, V's, K onto V's, and max by size. What do we get? Are we still getting the same thing? Yeah, we're still getting the same thing. Okay, I expected this naive version to work completely fine. So maybe we are missing something. Every set of V's such that all of them are connected. Let's take out this max by and see what it's filtering down to. I mean, oh, none of those are very big. Is this edge even group mapping correctly? What does this adjacency graph look like? Okay, I mean, some of these ladder groups are 3 or 4 long. So once we do that filter, we don't get any that are very big. Oh, hold up. Just because. Hmm. No, they should all be completely connected to each other. So the ko, which is the alphabetic first, should have de, ka, and ta in it. So let's just look at what aj ko has. So that should have de, ka, and ta. Oh, I think we just want the largest subset of those that are connected to each other. Yeah. Yeah, not everything ko is connected to needs to be connected back to it. Okay. Okay. I think I'm going to start taking advantage of the alphabetic ness. And we could do that for one. Let me just comment this out for bit. Let me just make sure the alphabetic thing works. So B always comes before C. So we should still get the correct answer if we remove the second check. And our original answer is 1476. So let's see that run. Come on. I know it runs fast. 1 second. 1476. But if we remove the second check, wait, hold on. It's not actually that straightforward. All the combinations of 2. In one order. The combinations aren't necessarily going to be in the same order, right? So CXY CPA, the combinations of 2 are going to be, should be in the same order as a thing, right? So, oh, maybe we don't want that many. CYXC. Reach my mind. Yeah, it's always going to preserve the order. So the combinations preserves the order. So B always comes before C, so the adjacency graph of B should contain a C. So we shouldn't also need to check that C might contain B. But I guess we do. Yeah, because that changes the answer. Okay. Good to know. Good to know. So we won't rely on that. Let's go back to our naive thing here. And so in the combinations, I just want, we want to filter the V's for, oh, I think we check the, so in the case of Kodakata, we had an extra bit. And how would we remove that? Well, I mean, we have a graph, the largest fully connected component of a graph. Okay, let me give myself a mental break. You're looking at the, oh, you're discussing Copilot. I'd be curious. I mean, I use Copilot. I'll turn it off and on because I think it often just barfs in my editor. But when I know exactly what it's going to write, it's helpful for like moving through a boilerplate. But you tried Copilot today to solve. I don't know if I trust Copilot to solve for me as much as like ChatGPT. Yeah, I'm gonna bookmark that thread and take a look. I'm curious. Huh. Let's whiteboard for a sec. Let's make sure I'm sane. Okay. So we have something like our and we know it's connected to everything in this set. So 4, 5, 6. Well, yeah, let's just give it a few connections. So we know it might be connected to like four things. Um, Now, we could check in alphabetical order. We check if this one contains all of the others. So if we could go back to the adjacency set and see if that's equal to these. And if it's not, there might be two cases, right? Like it might not be, well, yeah, there might be like some in there that's missing. Um, it might not have any of them. So let's consider that it has none of the other ones. Then we would go to the next one in alphabetical order. Let me just sort these by kind of in alphabetical order. So we have this, and it's connected to 1, 2, 3, 4. So this might be connected to none of them. Then we would check this. If it's connected to all the others, we're good. Right. So we might look for that. Oh, then after we see that this is connected to all the others, then we need to then check that this next one is connected to the remaining one. Okay, but now suppose we had a case where the first one was connected to, say, all the others except one. So let's say that's connected to that and to that. Well, it might be the case that these two are connected. This contains that, in which case we would be done. Otherwise, like the rest might actually be more connected. Yeah, we could keep cursing down a list. Never used Devin. Oh wait, okay. Devin is like a is Devin like an LLM that behaves like a coworker? It's a super slow junior dev. I mean, $500 could be cheaper than a junior dev. It's like monthly cost. Online cycling. What's online cycling? Okay, I could take this approach. It's just going to be long. So for each of these, we check all down the graph. I want to know how big these sets are. And perhaps we can just take, various combinations of each size. Yeah, I think this is manageable. It might be very manageable. So this, how big is this thing? Wait, what did this find? Right, this found the largest thing that's already fully connected. Right? So we could then find something. Oh, okay, at some point in this drawing, you're going to have a bit that's fully connected to everything else that appears afterwards. Right? Okay, I mean, so let's say your largest one is something that is like this, where it's connected to everything, and then there's a bit afterwards that doesn't exist. Then that isn't part of it, or that isn't connected to this first bit. Well, this one will have appeared like later on in the list, like it's connected to all of those, and those are all connected. Right? So basically, the largest fully connected graph is going to contain a first element. And then everything in there is going to be connected to each other, right? Wait, so did I already find the answer? Well, the problem we had was a case where co was connected to something else. It was connected to something else altogether that was not part of the graph. So all of these are connected to each other, yada yada. But then it was connected to something else. But then again, like co is gonna have within here, there's gonna be a largest connected bit. So de had ka and ta. So I guess we find the largest one. Will it work that way to find the largest one first and then find what's connected to it and all of its other? And then we just do that recursively until there's nothing else connected to any of them. And we just keep growing that. I think that sounds too easy. I might be missing some sort of case. Like we might be starting with the wrong kind of thing. Well, let's do some exploration. So if we just do this filter bit, and let's do a sort by size, negative size. So so these are connected bits. They're not all the fully connected bits, but they are some big fully connected bits. Right? Let's do connected map size. I want to see what those sizes are. Do you have a bunch of ties? Yeah, 11, 10, 10, 10, 9. Okay, so like one of these is going to be part of the actual winner. So we need to find something that is itself connected to all of these and more. What could possibly be connected to all of those and more? Let's do edge.filter. The keys or the values, that size is say greater than 10. Sort by negative size. And let's print those. If any of them exist. I want to know what these sizes are actually. So edge, we're just gonna map to get the size. Dot sorted dot reverse. Okay, what do we get here? Did I already find the? I have a feeling I'm going to have found the answer already. I don't know why this is not running. But this print line, none of those are very big. And we only had one that is of size 11. I think we already found the answer. I just need to put it in. I thought I tried putting that in. What did I actually input? Yeah, that has to be the answer. Just this naive thing totally works. So we're gonna turn this back into a max by. I know, just straight up ends too. Max by dot make string with the commas. Okay, we should still have the worksheet output. How many are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We did try this. That's the answer we're about to get. Um, so, I mean, this is a pretty large connected component that we've found, right? So any answer should be bigger than that, right? This is 11 things that are connected to each other. So there needs to be something that's connected to 11 other things. But what we've just, right? So there should be something that's connected to 11 other things. And that can't be the case if this doesn't list anything that's connected to that many things. Unless it's after it in the alphabet. There might be something that's after it in the alphabet. So it doesn't show up on the left-hand side. Right? These aren't full connection graphs. It is sort of directional. Okay, what I should just do is put both directions in the graph. Yeah, I'm kind of shooting myself in the foot by doing this alphabetic thing. Okay, we're doing a new adjacency graph that just has everything. So input.collect, we're going to flatten a list because we're going to make a list of both directions. List of A to B and B to A. We don't need to sort this. That's kind of like a silly early optimization. I didn't know what I was thinking. So this is a complete adjacency graph now. Should be. And now this should be, yeah, this should be empty. I mean, there is going to be a leftmost. And if there's going to be anything bigger, it's going to come from, like the rightmost is going to be attached to all of those in the other direction. And now there's not going to be anything pointing to something that's fully connected. I mean, I'm just getting back to this. If there was a rightmost, back at the whiteboard. So this is, the answer is fully connected. There's going to be a leftmost that is connected to all of them, right? If there's a rightmost that's connected to all of these, it would also appear there. So that's not how we get any bigger. This could also be solved by not writing code using the graph tools. Totally. I used a bunch of graph tools last year. I forget what my favorite one is. GraphViz. I think I did some GraphViz stuff. You could totally just solve it that way. I mean, that's sort of a little bit of what I was doing by just intuiting at this, right? Because no thing is connected to more than. Let me just comment this out here. I want to see. We're going to sort this adjacency graph. Edge dot sort by dot length dot reverse. So the second part dot length reverse. So it can be at most like that big. Edge dot to list. Okay. We found a fully connected component of size 12, right? Hold on, let me just pull that up on the right. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we found a fully component thing of size 11. And since these sizes here, wait, where do we do this? The largest one, oh, let's also get the sizes. I know that. We're just gonna map to the length and then sorted dot reverse. 13. Okay. So the largest possible grouping would be 14. There's something out there that's connected to 13 other things. We found a component of 11 things that are all fully connected to each other. And it could very well be possible that those 11 I found are not part of the full answer. You tinkered with the inputs until Graphviz fell over. Oh, you talked with our hyperneutrino about this. I'll be interested to see that too. I'm in hyperneutrino's Discord, and I've seen them posting about LLMs a lot. But I haven't really read it. Streaming early was an issue in the past. Oh, I'm definitely not in violation because I'm too slow. Yeah, yeah. No one's going. The global leaderboard is not going to be spoiled because of me. If I get that fast, I'm not streaming anymore. I might still record it and like post it the next day, like some people do. Or I'd have to stream on delay, and then I wouldn't be able to chat with people. Okay, where are we? We now have this graph that's fully connected. And now it's sufficient just to check, one direction of this connection to find all the triples. And I mean, I guess we could use that to filter some of these. And this no longer works because the adjacency graph isn't directly going to contain that. Well, I mean, if all the combinations are represented now, again, there's going to be let's just remove this max by for now. So these are all connected, right? From the adjacency graph, this is cases where all the values on the right side are fully connected to each other. And for the actual answer, is the answer like in what manner is the answer going to appear there, right? Because um, we have something that is fully connected. So we're going to draw this component here, right? And one of these is going to show up in there somewhere in our adjacency graph. So our adjacency graph is just one to a bunch of others, one to a bunch of others, right? So one of these is going to show up there, and each of those might show up there actually. Um, and when they do show up, the other five are going to be there. And the problem is that there might be extras, right? So this might have a red. So this is not going to show up in this connected list. Um, um, but the thing is, what is the relationship between these? Like, can I make use of this at all? Those 10-second solves, no one is that fast. I think I mean 1 minute. Like going off the videos on YouTube, I see some people doing this. Like I think 1 minute's certainly possible, right? You have it all set up. You have code ready to uncomment for what you think the easy problems might be. Grid, search, parse, whatever. Yeah, having the code pre-written is kind of yeah. I mean, I hesitate even writing a library. Like when I first started this, I wanted to write just everything completely from scratch. But I mean that's I would say that's self-imposed. A25 was designed to be solved with GraphViz. I can't remember if I solved it with GraphViz. I used it multiple times that last year. I had like 3 nights I used GraphViz. That was a new tool in the box for me. Oh, is this list showing up empty now? Okay, we need to be searching this in a different way. We should actually treat this like a graph problem. I think what I'm doing here is I'm looking for shortcuts. I'm looking for shortcuts that don't actually work, and I should actually do some sort of graph traversal. Um, so searching in a graph for the largest connected components. Um, I mean, searching for fully connected components. So we could search starting at any place. Um, right, then we bring in another that it's connected to, yada yada. Um, and then within there, well, I guess what we could do is recursively here. So we're checking that they're all connected to each other. Recursively in here, we should find the largest connected component that thing is a member of, and that'd be by checking combinations, the largest subset that are all connected to each other. And since there's gonna be no more than 13 in here, I think I feel comfortable just like dropping, taking different combinations at 12 and checking that they're all connected to each other, right? And then different combinations of, we don't have to search down too far. So the F largest connected, given a small. Oh, what's that sound? Hex tree. Welcome, welcome. How was your stream? Mincut? Mincut. Did I use Mincut last year? Uh, okay, we had our adjacency graph. I did a search. Oh. Um, what was the problem last year? So if reachable size 3, then we are still connected. Is this an implementation of Mincut? uh, Mincut has a. There's another side of the coin to Mincut, right? Mincut is also the same as max flow. Is that what it is? Mincut, max flow, same thing? Today was the first day you felt like you were fighting the Rust compiler. Well, fighting the compiler is not a bad thing, is it? The compiler is forcing you to express yourself properly. This is it. No. Yeah. Yeah. I think my implementation there is a Mincut. Um, so we want large connected out of, I guess, a bunch of nodes. And let's get a set of string. And we want to use that here. So here we checked if the combinations of 2 were all connected to each other. Here we were just searching for any 2 that were connected to each other. So I guess we could filter. So filter all the combinations of 2, filter all for all the edges, and then see which ones appear the right number of times. And then once we figure out which edge is missing, we take out one or both of those. So let's say we have what we should get is a connected component of 5, but we have 6 nodes in here. And let's say this diagonal one is missing. So we have the hex, and we have these that go 2 across. But we're missing this diagonal one, so we still have this, and we still have that. So everything else is connected. So we can delete one, check if the rest are still connected, or delete another. And we're only choosing to delete one or the other of those because they're not connected to each other. So do we delete that and try again? I think I did get lucky finding that size 12, well, finding those other components with the alphabetical version. I don't think the input was meant to like reveal that much. Just Barrett in with a raid. What were you doing? You weren't doing any Godot learning, were you? Uh, okay, let me catch up on chat a bit. Yeah, it is a good thing. You like Rust, but you don't have an excuse to use otherwise. Yeah, I think AOC would be fun to learn other things with. Like I've thought for a while I'd like to use it to play around with Rust. I want to play around with Unison using AOC. The Unison Discord's also doing AOC right now. Gamma 5000, welcome. Pineapple King. Um, yeah, so what you missed, I powered through part one, and I'm taking my sweet time on part two. Mm. But we've been having a good discussion about what constitutes cheating in AOC. Um, yeah, I was trying to find a shortcut, but I think I have to actually do some graph reversals. But it's feeling like that will be too slow or too many. Like this is gonna be like a factorial growth in like number of permutations I have to check. So I want to go back to searching for shortcuts. Um, right. I mean, we could look for combinations -1. Okay, suppose we just kept all of these nodes that are well, all of these edges, right? So we're like taking some of these lines. And how do we decide which lines to get rid of? Um, well, I guess you look at how often they appear. So let's say B is connected to. So we have our A, our main node that's connected to all of these, right? So B might be connected to, let's say A is connected to 5 things, right? So B could be connected to 4 things, et cetera, et cetera. 4 would be the maximum. C might be connected to 3. Wait, that'd be impossible. If nothing is, if anything is connected to 4, then we are done. We actually have a 5. So A would be connected to all of them. Since we're only, yeah, since we're only doing 6, so D, A, B, C, D, E, and F. So A is connected to 5. If any of these show up as 4, then we are done. Otherwise, maybe 3 is the highest number you see in here. Okay, so I think I can do that, right? So for each entry in our adjacency graph, we can definitely, like, there's at most 13. So for each of those, we check against the other 13. So it's like 13 squared, some small number squared. That's super manageable. So we can search that way. I think I was edging towards that idea earlier, wasn't I? And then I think I swerved off of that idea onto like the factorial search, and we don't want that. So we've got an approach. What are y'all saying? Gamma 5000 supporting the raid even from YouTube. Oh, right. He raided on Twitch and then you came over on YouTube to see it. How about that? Well, welcome. I'm sure it was a long trip to get here. I think YouTube has a thing like raids, but it is a, what do they call it? Redirects? It seems like less of a thing. What was perfect timing? You started a job in November. Oh, oh, the very first AOC. AOC is how you learned Scala and then got a Scala job. Nice. Yeah, I would. I think I learned a lot of Scala through doing Project Euler, so kind of a similar-ish thing. You've been using Scala for 10 years, so a serious Scala developer. I would have learned just before you, 2014 or 13. 13, I started playing around with Scala, and then I got my first Scala gig in 14. You have another hour in you. Well, lucky for you, I think I'm almost there. Um, let's do this. We'll do this smaller number squared approach. So we're gonna filter. We're not gonna filter. We're gonna do a map. So we're looking at our adjacency graph, and this is now the full adjacency graph. No like directional nonsense. And for each v, we want to know how many of the others it's connected to. So we want v's.map, and then v's.count, edge set. Well, okay, we have a v, right? Edge set v dot contains that. Okay. And then the largest number there. The largest number there is probably the cipher set. Why are we getting a syntax error here? We're not doing this as a filter, we're doing this as a map. For every v, we count how many it's connected to. And what even is possible there. So could they all be connected to 3, for example, in this one? So they all just have one other that they're not connected to? I think that's totally possible, because you could have some sort of hex. It's possible if they're even. So if there were 6 of these, then you could just say each is not connected to the opposite one. And then you'd have, I don't know, that shape. But now, is that shape useful? Like, how do we find the largest connected component in there? I thought I had an approach. How did I do the 2 to 3 transition? Oh, with advent of code. So, when did Scala 3 come out? 2020? Or 19, it started coming out? Or was like at least usable. So in like the pre-release, the release candidate started coming out in 2019. And my first advent of code was 2021. By then, it was starting to be more stable, and that's the point at which I was like, let's start using Scala 3 more seriously. So for all of advent of code, I've been using Scala 3. Your job dragged, and that's why you're not a manager. Yeah, I feel that. Human problems are sometimes way more complicated. I feel for you there, Marcus. Yeah, I mean that's another reason, a good reason to go back to Evan Code is to get some time away from management. I'm perfect for you to zone out to as a compliment. Okay, well, thank you. I'll take that to mean that I've got a relaxing voice. You use loops? No clue how to do this functional stuff? Oh, they're all just loops. I just use loops with fancy names. Um, Eesh. I felt like I was so close when I started. I feel like I'm straying further and further away from the answer, to be honest. You only ever use pizza? Wait, you seriously use pizza? All the way back? When did that? What? So like pizza was a precursor to Scala. So you studied at the university. So you were at EPFL back in the 90s. Yeah, Scala V0 or Scala V1. I don't know. There was never really a Scala 1. Scala 2 was really the first kind of production Scala. That's awesome. I've only met, I would say I've only met two people that use pizza, and that would be Martin and his son Jakob. So there you go. You're the third person I've ever met that has used pizza. Some pizza right now. Some nutrition would be great for Abnica. Nutrition and sleep, those are important. Okay. I think we just go to the factorial search with some smart pruning. We know it has to be at least size 12, and we just know that because we happened to find that out in our exploration earlier, right? We got lucky, and I should just take advantage of that luck and make a really slow solution work. Um, so these components are at most 13, right? 13 is the largest thing you can possibly get. Um, just get this compiling again so I could see that. I don't know. Okay, I wanted to see edge dot values dot map size. Okay, so I want the size number that we're connected to. Um, so the largest possible component at all is 14. Um, and I don't think that's actually the case. So for each of these groups of at most 13, oh wait, is everything connected to 13 other things? Seriously? Everything's connected to 13 other things. Let me just print edge for each print line. I just want to, I've got to see this. Yeah. Okay. I don't know why it took me so long to notice that. Okay. So for each of those groups of 13, the thing is, there could be some repetitions, right? There's a VV here. Phoebe's going to show up down later. If it's well connected to those others. Okay, so we could look for like the most connected of those groups as like a heuristic to shorten our factorial search. But if we're choosing 13 to omit to find a connected group of 12, we're choosing to omit one from 13, right? So there are 13 ways to choose that. And for the next bit, there's going to be 13 times 12 ways to choose what gets omitted. And I think the answer is larger than 11. So I think we can recurse down 3 levels, right? It really starts to grow once we're like looking at the middle bits, right? Connected groups of 5. So if we're only looking for large groups, I don't think the search might be too bad. So given a list of nodes, at most size 13, I know we can just enumerate these. Let's look specifically for 12. Yeah, let's look specifically for 12. So we choose 2 to remove. Um, so nodes dot. I'm doing this on gut. What'd you say, Eric? It took you a good while to figure out a way to do this puzzle and have each node connect to exactly the same number of nodes. Oh, geez. But is there a reason? Is there a reason that's necessary? Was that just for fun? I mean, the answer to that is spoilers, so you don't have to say anything. And you telling me the answer to that is spoilers might itself be spoilers, so you're off the hook. Who is the guy? You kind of look like the guy in movies that's super smart and can hack anything. Me? Oh no, not me. If I'm that guy, then here I'm role playing as someone who can't hack anything as cover for all my crimes. Why why is AOC.solve missing? I haven't implemented it yet. What would you do? Like package AOC def solve equals triple question mark. There we go. And it returns string. And it's implicit. The reason is mostly to hide the structure of the input, so you can't use that information to solve the puzzle. I mean, that makes perfect sense. So we can't cheat. I mean, I think doing this, I still think this was lucky here to find this group of 12 just by happening to like make them directed. Yeah. Maybe. I didn't know how to run with that. I bet someone else could have run with that and found the answer sooner that way. I don't know. So we're going to remove 2. So we're going to choose to remove 2. So nodes.combinations. Let's just say combinations to size 12. So removing 1. Wait, we already found. This had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did this already have so we already found something a size of 11, and it was the wrong answer. It appeared to be the largest thing. So let's find something a size 12, which means here we'll be looking at combinations of 11. So dot map We'll call these V's vertices. This one, adding the Open AI connector for O3 into Scala solve. Yes. Oh, yeah. That's exactly the implementation. It makes a network call to the OpenAI API. So for each of these V's, we're going to check that V's.combinations of size 2 dot for all, I know, yes, some A and B. A is connected to B. Right? So that's fully connected. And I guess we filter for these. So we choose subgroups of size 11. Yeah. And surely there can't be. So in a group of 13, can there be two fully connected segments of size 11? I suppose there could. Let me just think about that real quick. So let's say fully connected size 11, and then there's also this fully connected size 11, and this has two nodes that are not in there. Right, so there are two connections that are kind of missing at some point between those two. I guess there could be. And if it's ever more than one, then 11's the wrong size. So, well, connected combinations of size 11. So we filter based on our vertices if they are all connected. So if connected dot size equals 11 or is greater than 1, then we're going to throw. This is kind of hacky. I'm not going to lie. Is Scala a smart programming language? No, it is not an AI programming language. We just return that set connect. Hold on, we're going to make this an option to set. So do we find a connected node of that size? This no longer means largest. This means connected 11 out of 13. So otherwise, in the bind, thank you for the follow. In the blind, what am I making? I am making a solution to tonight's Advent of Code puzzle. So I want this to throw, and if this ever throws, then we're done. It's not size 11. It's going to be bigger. But otherwise, we do option dot when connected dot size is 1. Then we return that connected dot to set. Okay, so this will find a connected 11. And now we just do our adjacency graph. We're gonna mess a bit here. So Emperor Alex, thank you for the raid. How was your stream last night? Hmm. I didn't stay too long, but I hope you were well on the way. Very nice tuning on the noise gate. Thank you. The honest, that might be AI. I also have an AI noise remover. Yeah, you don't want to hear me yawning, because then you all will start yawning. You can just see me yawning. You had a good stream. Good, good. Um, well, what happened here? Connected. We want connected.head.toSet. Um, wait. We just want add set A and B. That will tell us if it's connected. And this is an iterator. We want to make this a list. Okay, so back down here, we have these values. And I guess we want to filter. Or yeah, let's do a filter. See how many of these we get. V's dot, let's see, connected 11 on the V's. Let's do a count actually. That is defined. Okay, so if there's a unique answer, then this count should show up as just 1. We got a not implemented error, which means at some point we found multiple. We found more than one fully connected component of size 11. So, so we know that our fully connected component is a size 12. Okay, 13 times. Great. So 13 is exactly what we want. So we're gonna just we have our answer. We have our answer here. So we're gonna turn this into a filter. I don't know, that map. Take the key. And then let's sort those. Sorted. And then make a string with commas. So I feel like I had a hacky way of getting the solution, but it's still a solution. Maybe I'm speaking too soon, but that has to be it. There we go. um, is that not hacky? I mean, the fact that we were looking for something a size 12, so there was nothing a size 13. This, the brute search wasn't even going to be hard because it would have started by just removing one, choosing one to remove from that set. Yeah. Thank you. All you heard is it gets a solution. Yeah, that's what I'm saying. Cool. Although that did cost me a bit of a delta, didn't it? What are we looking at here? We're looking for my stats. Yeah, I went from 927 to nearly 4,000. Thank you. Do you mind just walking through the bottom left of your illustration again? The illustration is a representation of my mental state. It's just this tangled web of things. Yeah, here I was thinking about the size of the search space, or I was trying to think about if we had two nodes. So we had a group of size 13, right? So if we were searching for a group of size 11, is it possible to have two different groups of size 11 within there? Right. So that's what inspired me to put in the breakpoint in case there was more than one. And since there was more than one somewhere, then I knew, I guess there would be more than one if there's something a size 12. So maybe I didn't completely think that through. But, if there's, in that case, then there is something that's bigger, which is a size 12. Thank you. Thank you. I think it's beautiful. This will go in my memorabilia folder. That's right, dead center of all my drawings for the year. Maximum Click was in fact the first proper program I had to write. Oh, Maximum Click back in uni. I feel like I've done this before, but I can't remember. I can't remember. I need to brush up on my graph stuff. Max Click. That's a good name for it. Yeah, I think I was just afraid of the search space. Um, I don't know if I want to factor this tonight, but I'll at least commit what we have. And this can clean up really well. Um, so maybe I'll just do that real quick. And then we could see who else is still doing this. That is rough as a first project. Uni wanted you to do it in C. You're fusing it in Python. I mean, I guess everyone has to do some C in uni. But debugging it was never fun. You also failed Kerbosh, which surprisingly worked. You used Kerbosh. I don't know what Kerbosh is. Kerbosh. The Braun Kerbosh algorithm. Okay. Um, and max click. So this is my reading list. The max click problem. Okay. Hmm. Okay, this will be good reading for me because that needs to be in my brain. Oh, you too. I know great artists that do not explain their art and let let it talk for itself. Well, thank you. The triple question mark is definitely a useful tool. All right, Gamma, thanks for stopping by. You had to do C for OSs. That makes sense. Um, oh, you're doing the original KNR book? I never read that in uni, but I did pirate it afterwards. Oh. Okay, so, oh, hummus, are you saying goodnight? Oh, to Gamma. Fair, fair. Um, okay, we've got a reading list. Let's do a quick cleanup here. So connected 11. This is actually connected 12. Um, so we're going to collect. This is just going to be a Boolean. So is there a set that's connected 12? So of all the combinations of size 12, we don't need this if connected thing anymore. Does there exist a combination of size 12? So we're going to change the exists such that all of those nodes, any combination of two nodes in there, are connected. Okay, and assuming there's no connected 13, then this gets us the answer. So add, I don't think we even need to list this. So we're going to filter, we're going to collect actually. Collect case where yeah, we're going to collect the case where V's is connected 11. So if connected 12 V's, we're just going to keep the key. And then we don't need this map 1 anymore. So we're going to do like a to list sorted make string. That's our answer. Okay, super easy if you take a guess at the size of the connected components. Eric, it might have been your downfall to have these all be the same size. Because if I hadn't seen that they were all size 13, I don't think I would have searched for a size 12 group. So in a way, maybe that made it easier for me. Okay. All right, Blue. Thanks for stopping by. I'm gonna call a night here soon too. But good luck with work. Airbosh space program. Just another Dutch programmer graph algorithm. Some of the Dutch are big into those. I mean, maybe there was some Dutch mathematician that was big on graph theory. I don't know why. So, Twitch advent of code. Who's online? Or actually, I might. Snowcone's online. Let's raid them. This is a good place to end the night. I think Snow is still catching up, but it's a pretty chill stream. So they're about to start 19, so we're coming in at a good time. All right. Well, good night, everyone. Thanks for stopping by. Hey, Tatus, Icy Black Deep, Lieutenant Hummus. Cool to learn that you've been doing Scala since 2015. And Hextree, thanks again for the raid. Eric, always good to have you. Oh, Carthage, I missed your message. 17, I agree. 17 was a favorite. All right, let's go raid Snow. The Horrors of 19. 19 wasn't too bad, right? 18 and 19 were break days. Oh, wait, is 19 the bad one? Is 19 the hard one? Let me just check. Day 19, 2024. No, 19 is fine. Okay. Snow will be fine. Let's go see how we do. 20. She might get to 20 tonight, and that'll be a fun one. Alrighty, sending. Oh, rated just as